Good afternoon and welcome to the 29th Annual Exhibit of Hydrogen Fuel Cell. Our next guest is already here. I'll introduce him briefly. It is Burkhard Harhoff, Technical Director of New Business at Poppe Potthoff. I love the name of the company. It's a real Zungenbrecher. And we'll be discussing PPH2, an introduction of a new material for hydrogen fuel systems. Burkhard, you have the stage.
Yes, thank you very much for the kind introduction.
Microphone?
Do we have a tone? Hi? Okay, thank you very much for the kind introduction. Ladies and gentlemen, I want today talk a little bit about PPH2, a new material option for hydrogen applications. We have one of the biggest transformations of the recent years. It's going from fossil fuels towards new sustainable solutions. Yes, and an essential solution for this is hydrogen. And hydrogen acts as an energy storage, but also as a fuel for drive solutions. But we at P&P have one question to that. Is it really necessary to use stainless steel, or are there also other cost-effective solutions in the market? And I will show today how we developed and validated an alternative material solution at P&P. I wanted to speak a little bit about our right to play in this area, who we are. We have deep expertise in metal processing. We have customers from numerous industries, and we are successful worldwide as a family-owned company. We were now more than 90 years old, have 16 subsidiaries worldwide, and have also are working in various industries. You see a customer reference list over there, well-known customers, where we are supplier. What is P&P's expertise in fluid management and alternative technologies? You see here over the graph the expertise growing over the years, and many of our business models have explored out of tube manufacturing processes. So the tube material, exploring new tube materials, were a success factor very often in the past, and are also leading two components which you see on the right top side, for example, valves and on-tank valves and pressure control valves. The rising steel prices have been the ignition for our material innovation. What you see here is from 2020 to 2021, the stainless steel prices have increased significantly. You see it at the red arrow. This, together with the poor availability sometimes for some stainless steel sorts and dimensions, is reason enough for us to finding new options. In the first step, we did a benchmark, and we found solutions in the chemical industry, but also in pipings and pipeline materials. So here's P&P material answer for a growing hydrogen market, the PPH2. So the task was to develop a material category to increase availability for hydrogen lines. Our target system was for mobility solutions, so passenger cars and trucks, so 700 bar storage systems for fuel cell and combustion engines. The material we have chosen is an alloyed, quenched and tempered carbon steel. The alloying concept binds the hydrogen penetrating the metal matrix. Together with that, we have a heat treatment, and the mechanical properties are improved by a defined heat treatment, so-called PPH. The grain size is 6 and lower. We have a high pressure resistant and fatigue strength, and you are also able to form these pipes thanks to its higher elongation. So yield strength is above 650, tensile strength above 750 megapascal, and so PPH2 is a very strong material. What have we done? We have done material tests and component tests. Material tests, the first we have done is according ISO 11114-4. Secondly, we have done the so-called CHMC1 test. That's a test more used in the US, but also I want to go more deeper in the details of this test. You see the certificates here, so the material is certified. So the technical background for this test CHMC1 is hydrogen gas environments alter the mechanical properties. The main effects are a reduction in ductility and crack initiation. The test procedure is a slow strain rate tensile test with special notched tension probes. And the test output at the end is a comparison of force results until crack in hydrogen and inert gas atmosphere. You see here the probe preparation for the CHMC1 testing. It's a complex form, even if it looks simple, but the crack initiation notch is very sharp and special. If you look at the specimen fracture pictures, you see here, we see in the middle a fracture picture or surface of a probe which broke in inert gas atmosphere, and on the right side, one which broke under hydrogen environment or in hydrogen environment. You see very clearly a light gray diffusion zone, but the diffusion zone is not so big that it has an influence more than 20% on the results. Evaluating the test results of PPH2 in hydrogen atmosphere, it's at the end a tensile load ratio between inert and hydrogen atmosphere, so-called RNTS. And we have here an excellent value of 0.81. 0.5 would be the limit, and 0.81 is much above that. And so this material, according to this test, can be used. That was the material. The other point is the component test itself. We did an extensive test program according to EC 79 and to HGV 3.1. You see all the tests which we did. The ductility test, the corrosion resistant test, the endurance tests, and so on. And I want to go deeper into the HGV 3.1 5.8, which is a very hard corrosion test. And that is shown here. We did this test with different material combinations. So you see on the right side the test parts figures, how they look like. And we have made the mix of parts of stainless steel, of PPH2, a carbon steel, and of aluminum. And in all of these combinations, we had functional-wise very good results. The function was given, even at the end leakage test with good leakage results. Nevertheless, for example, PPH2, the carbon steel, if you look on the electrochemical row, you see that carbon steel, the distance to aluminum is lower than, for example, stainless steel to aluminum. So that makes the PPH2 choice we have chosen here even better. The coating, the outer coating and protection of the material is a zinc nickel coating, so that we have outside also protection. That's it here. So I come to the last slide. P&P's material answer for the growing hydrogen market. The advantages of a PPH2 in one glance. The PPH2 shows excellent results in hydrogen capabilities, so we have all the certifications, we can use it. PPH2 saves weight and space because of the high mechanical properties, which are in much cases higher than the stainless steel properties. PPH2 is a short-term available solution in comparison to some stainless steel sorts. And PPH2, carbon steel, has a better CO2 footprint at the end as stainless steel solution. The footprint is nearly half of the of stainless steel solutions. So that's in a glance. And yeah, I'm open for your question. Thank you very much. You find us at E16. Thank you.
Thank you. We do have time for a question or two because we thankfully finished ahead of time. Are there any questions from the audience? I'm surprised it's taken this long for us to have another exciting presentation with engineers trying to create a product and see if they could destroy it. Basically, testing like this is rather exciting. We used to have carbon fiber tanks under 700 bar, and you'd have engineers shooting rifles at them and throwing them into fires. But the question I'm asking really is, all of those tests that were so dramatic, they were really related to a specific application. And the one message I didn't get is, where does your material science play into a functional role? Are we talking about pipelines here? What specifically
No,
is
we
the
are talking about 700 bar applications in storage system of trucks or cars.
Okay.
And this is our first approach. I'm quite sure that there are new business models also in other applications, but this is our first approach because we are automotive supplier firsthand. We are also doing business in industries, but this is our first approach. So the dimensions we are talking about of pipes are very small, a quarter of an inch or 10 millimeter, 12 millimeter inner diameters, and this is the business we are talking about.
And are these more stationary units, or are they also potentially mobile applications?
Sure, both. We are looking on both applications because we see a lot of in common there.
Whenever anyone mentions the weight, you kind of think, oh, that's the tip of the hat to the mobile applications.
Yeah.
It's been very informative. I think the details, of course, are things that need to be discussed at the booth.
Yeah,
because
I would appreciate any question or a discussion at our booth.
And so the booth number is
E16.
E16. Okay, yeah. Visit Burkhard Harhoff at E16 to continue the conversation there. And we'll be back in a few minutes with our next guest.
Thank you very much.
Thank you.